So Baseline Protocol is an open source standards-based body that is under the OASIS umbrella. And what we are is, it is a way of enabling multi-party data sharing under zero knowledge. So we want to give you a little bit of kind of background and a little bit of color around it as far as how we got to setting up this type of solution. So you start looking at, within the large enterprise cross-industry landscape, you started to see within the past 60 to 75 years moving away from single entities that went ahead and pursued vertical integration. They wanted to control everything from end to end, bringing all their processes in-house, and they want to control that end-to-end process. Probably the most famous example of that is the River Rouge Ford Motor plant in Michigan. That's actually where the Mustangs are made. Or they were up until recently. But that was a completely vertically integrated plant. It had its own foundry. They made all of the component parts, and then they assembled the vehicles. It was massive centralization on an industrial scale. And around the 70s, they started to realize that this was very inefficient and really did not evolve with the times when it comes to the efficiency and the gains that can come from network partnerships, starting to collaborate externally outside of your corporate borders. And this started to grow to where it's like, okay, it's a lot easier if we went ahead and bought whatever component part, or if we're going to rely on any type of service from a smaller entity, it's a lot better to collaborate with them. And this collaboration really started growing. And along with all of these shared business processes, you had a no small amount of data that started to travel between them. And that data, people started to pay attention to, because it's like, wait a minute, some of these people can gain some insight of our competitive advantage and use it to either get ahead of something what we're doing, beat us to market, or disrupt us to where we are going to delay our journey to market and get the reputational damage that comes with that. So it really started to become a, there we go, multi-party coordination. And this was, really grew extremely rapidly. And right now, according to Gartner, you've got 75% of all organizations are exchanging data with their external parties in these manual, frictioned workflow environments. You're going to need to find out in a manufacturing finance application, does this purchase order match this invoice? Does it match that bill? Those are going to be coming from different sources. And is everybody working on the same data set? Most of the time they're not, because everybody has their own individual work environments that they are protecting all of their competitive information on. So making sure that everybody is operating from the same data set really became a problem. And how do we actually solve this? Well, we want to share data. And a lot of them say, we really want to share data, but we're a little bit nervous about doing it. But the studies had been conducted, and they come to find out that these enterprises that are going to share data with external partners are going to be 3 times the beneficiaries of the economic benefit. It's a lot quicker, it's a lot more efficient, and it's a lot more collaborative. And it also enhances business relationships as well as in creating ecosystem partners. It also can give rise to creating consortia of people within a certain industry, how they're going to kind of collaborate and advance just certain industry standards that everyone can benefit from. And really by next year, organizations that promote data sharing are going to outperform their peers on most business value metrics. You need to be able to see who is in the next lane, who are you collaborating with. But there is a lot of problems that come with that. So, but actually let me back up a little bit. And since most of these processes right now are very friction manual processes that basically where people have to get up and say, how do I know that my purchase order matches that bill? How do I know that you and I are working on the same data set? But I am not allowed to share my data with you, nor would I want to. So we have to play this game of go fish until we can finally get aligned. This is a way it makes it happen almost instantaneously, and you can automate these workflows. And we've got a couple of metrics up there to where 30%, and these numbers seem low. And this is just the data that is pretty much everyday data that is not sensitive or protected by some type of regulatory framework, which means 70% of it is. It's too sensitive to share. So, but even within these manual processes, 33% of those are going to have errors. They're just going to arise just out of the normal course of doing business with other human beings. Someone might fat finger a digit. They might put a decimal point the wrong place, and you are out of synchronization. So which means you have to sit there and pause, and you've got to do whatever make good operations that you can before it happens, but most of the time you're not going to find out about it until after it already happened. And that's when that's when reputations get damaged, and that's when there's a lot of finger pointing, and everybody wants to find which throat do we choke on this. So, plus sharing data is going to, from a security standpoint, is going to dramatically increase your threat surface. Anytime you have data in motion, as we know, you basically expose yourself to prying eyes. Plus, you've now created this additional threat surface that you have to control for and constantly monitor. And then, of course, when it comes to happen with data breaches, it's really interesting because so many people, if you start reading any of the news articles about data breaches, one thing that kind of sticks out when I read them a lot of times is most of them aren't discovered till like 3-4 months after the breach occurred. And I'm like, so this malicious actor has been able to go around unfettered within this enterprise environment. And security profiles are defense only. They can't go after anyone. So they have to basically either make the walls thicker or taller, which trying to do any type of transformation like that is going to be pretty difficult because you've got to collaborate between the business and the non-technical domains. As far as where does the investment come from, and but these data breaches are generally caused by that data being in motion, or it is being stored on a third-party site that's going to basically have custody but not ownership of your data. And so, and the cost of data breach is around $3 to $5 million. I mean, that's just for a low-level data breach, just in lost opportunity, reputational damage, and getting back to the day before it actually happened. All of that collaborative work. So, but the problem with existing collaboration is many companies now are aware of the legal and compliance frameworks. Many regulations have come down the pipeline, and they basically want to have assurances that they are still working with their external parties. Are they aligned? Have they been able to maintain a constant universal state of synchronization? And if you think about something that simple, translates into so much benefit, just knowing that everybody is working off of the same data set. And this is pretty much, cross industry, I cannot think of an industry that does not rely on external party data sharing. And those that do, it has to happen under very draconian data privacy frameworks, such as HIPAA, such as PHI, particularly within healthcare. In fact, you've got a lot of industries that, they want to innovate, but they're like, we're not allowed to. And they kind of engage in this mindset that psychologists call learned helplessness. It's like, we know we want to do this, but we just can't, because of either our security profile or data privacy. And that's the compliance headache, because compliance reporting is now becoming more widespread, and you need to have a very tidy reporting output. And a lot of this stuff is going to include data that you don't own or control, and you need from your external parties, and they are going to need the same from you. How do you sit there and allow this type of collaboration so that we have a full compliance reporting function, and so do that of our counterparties? There are right now over 4,200 regulations that are on the books right now. About 800 of those have been granted enforcement action. They've been given badges and guns. They can basically not really lock you up, but they can fine you. And if someone decides that you are out of compliance and you owe you have to pay a penalty for it in the term of monetary damages, you have no one to advocate for you. There's nobody in your corner to say, wait a minute, there's no appeal process. There's no ombudsman to sit back and say, no, we didn't do this, but we did all of this. Why are we getting fined? Well, the best way to avoid that is to have a nice, tidy compliance reporting to begin with. But you can't do it on your own. You have to rely upon several external parties. You've got to extend your reach beyond your corporate boundaries for the data. And what we do is, so what we are is basically opening up the mindset to where that is allowable. How do I actually share data and the insight from that data without actually taking custody of the data itself? Because that's going to put me outside of compliance, and it's going to really get me in trouble with my security team. So many of these solutions that are coming out there are generally part of a much larger digital transformation. And when you're trying to actually, they say, boil the ocean, when you're trying to do a huge enterprise-wide digital transformation, most of those are probably going to fail. Just because of the human factors, and there has not been a thorough enough assessment of what is important, what is prioritized. But everyone needs to move into the digital realm and undergo these transformations. Healthcare right now, which is probably the most constrained industry out there. Any type of health data or personal health information is completely locked down due to these laws. You have very, very controlled methods that you can access and obtain health information. And if you are not a doctor or if you're not some type of medical provider, you're not going to really be able to access that. But if you are a consultant or you are a service provider for a healthcare company, it becomes a little bit difficult to how can you do your compliance reporting when you cannot get anything in this HIPAA-constrained environment. So healthcare, of course, supply chain, anytime that you have multiple parties that are not members of the same legal entity, which is going to be within the supply chain, how do we make sure that everybody is working off the same data set? Now, there's been a lot of use cases that have come out. One that was called Food Trust, that was incubated by IBM and Walmart. And what they wanted to do was they wanted to be able to have that track and traceability upon any type of good that moved, for foodstuffs that moved through through the supply chain. And the reason why they wanted to do that was they wanted to be able to pinpoint anything that went wrong in seconds. Right now, if you need to find out which batch of strawberries or which heads of lettuce, became in contact with listeria or salmonella, we can sit there and pinpoint the farm where it came from, or the courier to where it came from. Under the existing environment, that took a week to 10 days, and that's assuming proper record keeping, which didn't always exist. But this is a way that you could take it down to seconds, and you can track this. That's one that had come out of the mist. Finance, of course, the data sharing in very packaged form so that you can maintain compliance is no small expense. It's about 20% of the operational cost. 40% of that operational cost is in this reconciliation, this back office alignment, because people do not want to share data outside of their corporate borders, but they need to. They need to collaborate with third-party providers. They need to collaborate with underwriters. They have to collaborate just through the entire financial services universe. They need to collaborate, but they cannot actually allow that data to move. What can we do to make that happen? Telecom. Well, telcos right now are kind of interesting because telcos are unique because they have these very entrenched networks, but they have very unique data that everybody wants. They can give you up-to-date, real-time location and movement data. So say you're I don't know, an architect or a urban planner, and you want to build a mixed-use live, work, play type of environment, and you want to find out, okay, how much movement, how much foot traffic am I going to be able to have in this area? If you have some vacant spaces in your retail component, how can we sit there and entice people to come in there and lease from you because, hey, we can give you this much foot traffic. And telcos are unique that they can provide that, but that was considered personally identifiable information as far as the tracking and movement, and so they got a big slap on the wrist for that one, to the tune of 209 million. That was a big thing to say grace over. But right now, you have telcos that have these enormous data lakes, and they want to monetize them somehow because they at least want to somehow get their costs back, from having to, maintain all of this. And so there's not a way that they can actually allow that data to leave their enterprise. So you're starting to look at different solutions that are emerging out of the mist, to allow people to share the inside of that data in a trusted execution environment. And there are different techniques that they're using, like fully homomorphic encryption, which requires a lot of technical overhead to set up and maintain, and it's also really slow. Why not use, a different technique? So, but all of that, these are all just wishes and stuff if everybody is not operating from a common standard. Yep, standard way to coordinate. So it's basically a standard way of coordinating, because how do I know that my data taxonomy, my data, custody, procedures and processes match up with those of my counterparties? And what happens, I can maintain this with the people that I deal with every hour of every day, but what happens when I have these arm length transactions, these one-offs, or these lower volume partners that I need to share data with, but we don't really have that onboarding process, and they're not completely whitelisted within my IT department. So how do we actually be able to collaborate without giving up anything or exposing any of our data or our compliance? And going back to a lot of these digital transformations, where they came up with, McKinsey had come to find that 70% of them fail. They do not achieve their stated objectives. They probably will only get 3 out of 10 of their, what they want to accomplish in their digital transformation. Mainly because, there's a technical aspect to it, but you have to retrain people, and humans are very imperfect creatures, and they're used to doing things a certain way. They're creatures of habit, and you have to teach them a new, different way of doing it. And that is, of course, assuming that the solution integrates and implements well. And how often does that happen? Practically never. So a way of actually, instead of using fully homomorphic encryption or using these trusted execution environments, a much more lightweight technique that we are introducing is what's called zero knowledge cryptography. And ZK has been around for 45 years around in there. It was really came out in the early 80s. And it is a way of basically having cryptography to where I can share an insight, I can share a mathematical proof of a secret, and I can then prove to you that it matches up with your data set without me ever showing anything to it. So a little bit about how that works is, the simple way is, you've got collaborators within a multi-party process environment. They will go ahead and take their data, and they will run it through a zero-knowledge circuit. That will give that data set a digital fingerprint. And then there's the collaboration on the baseline. We compare the fingerprints. So no data ever leaves the enterprise. So, and that's one thing that, humans being, imperfect creatures, kind of cannot get their heads around, like, how can something be proven to me without you actually showing it? And so it's like, well, we understand your concern, and I can't show you the secret secret myself because I'm not allowed to, or I just don't want to. But we need to collaborate, and we need to make sure that we're working on the same data set. So I can't show you the data set, but I can show you a mathematical proof that my data matches yours. Does that cross your threshold? And we haven't had anybody say, no, we haven't. So zero knowledge is a way that you can actually prove consistency between disparate data sets. And you have different areas of it. Like if you look at range proofs, this is probably one of our favorite examples. If you want to buy, a 6-pack of beer or a bottle of wine or, some vodka or whatever, all you need to do is prove to the threshold that you are over 21. So, or if you need to gain access to a club, and so you whip out your ID. Well, that's just to determine, yes, I'm over 21. I can actually buy this. But it's also showing the person that's looking at it, my height, my weight, my eye color, my home address, all of that. And, can you imagine if you're a young girl that's going out to a club and stuff, and the bouncer goes, "Oh, you live down the street from me." We don't need to know that. That's what's called a range proof. I mean, all you need to prove is this within a specified range? You don't need to know anything else beyond that. Transaction proofs are another example, to where it's like you're going to record the time, date, and disposition of whenever an exchange occurred. So that's really important when it comes back to data privacy, or if you have to do some detective work post some type of disaster or some type of thing that you didn't want to happen. Authentication proofs, basically, yes, this party has been proven to a certain standard of authentication, and we are not revealing any of the details of that. We are giving you the proof. So much of this is being replaced by a mathematical output that basically proves consistency across, and it's very scalable across multi-party, even, it is not constrained due to time or region. So you got inclusion proofs. Hey, is this part of a required set of attributes? Should it be there or should it not be there? We can basically prove that yes, no, it achieves all the parameters. Randomized proofs, that's one thing that's really starting to come out of the, really emerge out of the mist, as it were, is verified random engines, to where people want to go ahead and prove that, hey, this was done purely random. There were no fingers on the scales. There was no confirmation bias anywhere. This is a purely random output. And we can actually take that output and display it as a zero-knowledge proof. And then you have equation proof. That's basically, does this match up with what you have? Are they equal within certain parameters? That can be set by the use case or by the user. So zero-knowledge proofs really are a much more lightweight way of maintaining that obfuscation and the anonymization of the data, but you're still able to complete your work step and your workflow within your common process environment. Question? Oh, okay. So, right now, enterprises handle this anyway with these very friction manual processes. What we want to do is make it as close to automation as possible, and where appropriate, go ahead and automate these types of interactions. So, and by doing this, you are preserving all of your compliance. You are preserving all of your security profile. You are using your existing systems. You are using your shared business logic. We are not rearranging the furniture. We are asking basically an overlay and putting together a zero-knowledge proof engine on both ends of the bridge that basically allow you to have that synchronization and be able to prove it. Your word isn't good enough. Because a lot of times, again, humans being imperfect creature, it's much better to have that proof, not that attestation or that assurance. We want somebody that can actually make it completely random and anonymized and completely free of bias. So this allows it to be completely secure, data stays at rest, highly performant because you can prove a universal state of synchronization. And if you need to take that a step or two further to say, I need insight from that data, I don't need that data, but I need insight. And this is similar to like the telcos that want that location and movement data. How can we give you the insight, but without actually sharing the actual data itself, which will make us get in trouble with probably a dozen regulatory agencies who are going to all give their own fines and stuff. So that's how you have that coordination with modern cryptography without making it more difficult than it needs to be. So that is what Baseline Protocol really came out of. And Baseline Protocol was released March 4th of 2020, which was an interesting time to be releasing something new because we really were being drowned out by all the noise in the news cycle back there with the ramp up of COVID and all the different response mechanisms to that. But EY, Consensus, and Microsoft got together, and this was basically the, most of us were grizzled veterans of blockchain, managed blockchain platforms, use cases, proofs of concepts, MVP, and all of us really had done so many laps around the track that we said there's got to be a different way of doing this because we saw so many problems with the actual implementation. It was dynamite on paper, but the more we tried to get into it and start to really socialize and explore it, we come to find out a lot of limitations that pretty much rose to the surface very quickly. A lot of them where you had the bifurcation of the private blockchains and the public blockchains, and to where everybody has the same copy of the ledger. You have that single source of truth. Well, public blockchains, you don't want that much transparency. You cannot put any sensitive data on a blockchain. Plus, given the architecture, blockchain actually got a lot slower the more people and more data that was introduced to it because of that constant replication. Within the private permission model, that was where it was a way of bringing down the silos, getting rid of the gatekeeping, and everybody can have access to the same copy of the ledger. Basically, you're creating a digital nudist colony. People don't want that much transparency. I don't want to see what everybody else has. I like having the fact that I just can have the visibility into what we have, but at the same time, we are ingesting all of this new data, every tick of the clock. And what do we do with it? How do we secure it? How do we manage custody and access? And so that is what Baseline Protocol was addressed to address all of these shortcomings that we had seen within blockchain. Plus, blockchain took on a life of its own. Every term within there has its own baggage attached to it. You just mentioned blockchain, somebody's going to say, oh, Bitcoin. And then that's a 2-minute sidebar to say, no, it's not Bitcoin. Bitcoin is an application of blockchain, like a search engine is an application of the internet, okay? But that's about all that's where the similarities end. So EY, Consensus, and Microsoft got together and said, there's got to be a different technique of actually doing this where we have this enterprise data sharing, but also how we can enable this data sharing that extends beyond corporate borders. And how do we do this in a privacy-preserving way that is going to not make us run afoul of our security profile or our data privacy compliance? So, and plus, how do we do this without rearranging the furniture and without an enormous capital investment? And so that is how Baseline Protocol really emerged. Because we do have consensus, we have a long-standing relationship with Ethereum, and that was what our original code base was based on, is of using the Ethereum mainnet as that bulletin board for the zero-knowledge proofs. So you have that that immutable, append-only distributed database, but that is all it is. Only thing ever being stored on that blockchain is the zero-knowledge proof in fully encrypted in form. And just say you had enough horsepower that you could decrypt that, all you would be getting would be the plain text of the zero-knowledge proof. There's nothing behind those walls. There's nothing of any value or actionable beyond that. So it's almost a no-brainer. So, however, as the use cases start to evolve, we come to find out that, if you want to use a blockchain and say you have some concurrent projects that are using Ethereum, it's perfectly compatible, even native to Ethereum. So if you want to start introducing smart contracts, if you want to start introducing tokenization, blockchain plays, or Baseline plays very well, seamlessly with all of that. However, if you don't want to have all of the overhead and expense and headache of having to maintain your node, you can basically use anything that is going to be a bulletin board that can function, that is going to be forward-moving, append only. So if you want to use a DAG like Hedera Hashgraph, or if you want to just use an internal bulletin board within your own enterprise, this is a way that you can actually do that, or even create a consortium. So, but my team has put together this has put together this, and it better play, has put together a video. It's called the Little Bit video, and it's actually kind of campy and quirky and stuff, and we're actually really proud of it. So, but it's called The Little Bit. Yes. Mother.
Look there. Know what that is? Why, it's a brand new piece of information. Hi there, little one. I think I'll call you Bit. Bit is important. Bit represents real value, real things. We better put you somewhere safe, little Bit. There.
Let me pause this and see, because there's visual on this, and I need to basically move outside of. Because it played earlier.
Yeah, when you weren't in presenter mode.
Yep.
Yeah.
You may get out of presenter mode?
Yeah.
I'll get out of presenter mode. This is exactly what we were trying to avoid. But I really want you guys to see this. How are we doing hyperlinks? See a way that I can actually go to the browser and play a YouTube? Come on. Pardon our progress. Damn it.
Why, it's a brand new piece of information. Hi there, little one. I think I'll call you Bit. Bit is important. Bit represents real value, real...
What?
things. We better put you some...
Start over.
Look there. Know what that is? Why, it's a brand new piece of information. Hi there, little one. I think I'll call you Bit. Bit is important. Bit represents real value, real things. We better put you somewhere safe, little Bit. There you go, into your own secure information management system run by the company that loves you. It used to be that Bit could live its whole life comfortably inside its own walled garden inside one company. Today, Bit's real power is how it's shared between different companies, letting them automate and synchronize their operations to produce goods and services together. For Bit to do its job, it needs to make sure that everyone has the same bits. Somehow, every copy of Bit needs to be in sync with the others. But here's the thing about bits. It's easy to change one without changing the other copies running on other machines. When this happens, bad things can happen. Production grinds to a halt. Payments get held up in disputes. Partnerships fall apart. Trust is smashed, and fortunes are ruined. Now, big companies with a lot of cash to spare have known for years how to keep Bit from running amok. But they all involved either making one machine the primary source of truth or spending capital on dedicated integration machines. All these methods created more information silos to manage. What a mess! Poor little bit. A different approach is to keep bits in sync in a loosely coupled way. All the bits have to do is subscribe to the same spot on a common bulletin board, and they can be sure they're updating together as they should. A special cryptographic symbol called a proof is placed on the board so that bit can stay in sync without exposing any information to anyone else that may have access. Done right, it's impossible for observers to know who is depositing proofs on the bulletin board, or even to discover rates of actual activity. There's nothing new about this design pattern, but until now, companies had to spend capital to set up these proprietary bulletin boards for every new set of partners. That's expensive. Unlike those old bespoke bulletin boards, the public blockchain is supremely tamper-resistant, which means Bit doesn't have to worry about someone changing or deleting the proof it's using to stay in sync. And remember, it does this without putting any actual information on any kind of blockchain. The industry standard for using the public blockchain this way is called the Baseline Protocol, and you can learn more about it here at baseline-protocol.org. Go there now and learn how to both liberate and protect your little bits.
How'd you like our video? Wasn't that fun? Huh? Even, and that's how we actually put it together was. Let me get back into. Okay. Well, this is a different, from the current slide. So, there we go. Actually, let me go back. What do you guys think of the, it's pretty much trying to make it as simple as it's supposed to be. And we get a lot of people that come in there and say, what do you mean? I've got to buy all this, new infrastructure. I've got to buy something else on this because, I heard blockchain, and I know that means I've got to, set up and host something on there. And it's like, no, you don't have to use blockchain. And if you're already using it, this is a way that it will be plug and play into this. It is a way of using blockchain as middleware, but you don't have to actually use any type of blockchain. It does help by using what we call a CCSM, any consensus controlled state machine. Anyone that is going to arrive from a consensus method into a state and being able to prove that state in multi-party environments is how that actually is going to move forward. So let's get the little bit out of there. So really the utility on this, and I have to apologize for the slide making you guys work and do a lot of reading and stuff, so I'll jog through it a little bit. But what this is basically you're allowing to have a proof of consistency within your multi-party process flows. And you're allowed to onboard and offboard users at will. And you're all going to, but you're not ever sharing any type of data. You're not introducing really anything that is going to create the liability or even the exposure that you could completely break your security profile or your privacy compliance. And you can use this programmable type privacy to where you can set agreed upon parameters within your shared business logic as to who can access, who can interact, who can execute within this shared workflow environment. But the big thing is all of your data sets are constantly synchronized, and you can prove that synchronization. And yes, it is that simple, because from that simple synchronization precipitates so many solutions to common business problems that people are like, I can't see beyond the reach of my own corporate boundaries. So if you sit there and you look at it, it virtually eliminates your back office reconciliation costs, which are probably going to be about 40% of your operational overhead, is this reconciliation, this back and forth. It takes your cycle times down to seconds, and you can now prove multi-party coordination within your shared workflow environment. So, and then you can also coordinate your existing systems of record. This does not require any ripping and replacing. This will overlay your existing technology, preserving all of your existing governance, risk, and compliance. All it is it's an overlay. It is that simple. And that's one of the things people go, I'm not used to something being that simple. We're like, yes, and you're using a cryptography that is very lightweight. And we are, of course, using this bulletin board as the CRUD layer. You know, this is where everybody can go ahead and access the proofs when they need for their data privacy compliance. Because I don't have the data because it's not available to me, but I have a mathematical proof that this data matches my compliance reporting. So if you sit there and you start to look at, you know, the trust aspect between multiple parties, how do I know you're on the up and up? Especially when you have somebody that's new to the environment, or these arm length one-off transactions, or these low volume partners that, you know, you may deal with, you know, every quarter or maybe every couple of years, but you have that common business process. This is a way of onboarding it and making it completely plug and play. So, a lot of the, you know, common, since this is a standards base, we have, you know, common enterprise requirements, and there's nothing exotic here on anything. You are going to have, you know, established private business logic within your common purpose. You're going to have allowances for identity and discovery. You know, are you guys who you say you are, and are you on the up and up? And we can now engage in our process in complete synchronization and messaging. You know, from a technical standpoint, you could say it's almost fancy Kafka. But none of the data will ever leave the enterprise. So that's the beautiful thing about zero-knowledge proofs, is they basically will establish whether it's going to be a transaction, a moment in time, an interaction, any type of proximity or adjacency. All of that can be handled by a zero-knowledge proof. So at the same time, you can go ahead and start setting up corporate org registries, what we call the global phone book. These are all of the people in there that are baseline compliant, or that are already baseline familiar. These are the people that are actually are baseline ready. So we have a phone book to where you can allow that setup and onboarding to happen very quickly. And you have that private and stateless message bus. In fact, early on, we used to say that we used to have the magic bus, and in our online office hours meetings, we used to actually play the Who's Magic Bus, you know, as our bumper music and stuff. But at the same time, if you want to start putting in process tokenization, by all means, this is native to Ethereum and pretty much any other ERC compliant networks. So we grew up with Ethereum, but Ethereum is most assuredly not a requirement. So when a lot of people come in there, they say, you know, well, how do I know if baseline is right for me and stuff? I'm like, well, take a look at what you do right now. I mean, is, you know, a lot of your, you know, multiple partners and, you know, making that interaction simpler or even automating it a primary requirement? And do you need to somehow shield certain people during, you know, certain execution environments so that they don't have any prying eyes? You can go ahead and put that together. You know, do you have your small and mid-size, you know, people that may not be fully onboarded, or you have a one-off, you know, with say a small fabricator or someone that does, you know, a bespoke type service? You can go ahead and set that up. None of your data leaves. Doesn't require an enormous capital expense. You're not building anything new. And that's what I think was probably one of the biggest mistakes, that well-meaning mistakes that we made, those of us that you know, were in the blockchain space, because we never contemplated where is this blockchain architecture going to sit within the IT universe. And so because so much of the utility and the business uses that we wanted to address contemplated that we were going to displace an ERP system or a CRM system, or both. And those are multi-million-dollar investments with painful implementations that nobody ever wants to go through again. Those aren't going anywhere. However, with baseline, you basically will take your existing systems and you can now extend the reach beyond your corporate borders to allow that you can collaborate without any of your data ever moving. That's the key thing, to where it's like we can give you the insight and we can give you the proof. We are all working under the same data set. We actually had conversations with a global enterprise who in their, wait a minute, in their process environment, they use Excel. And this was, a global organization that had many moving parts, and all of that was being coordinated with this massive spreadsheet. I'm talking 90,000 columns, 200 plus thousand lines and stuff, this massive data spreadsheet that required an on-premises small army to actually maintain. And when they had all of their global program managers needed to access certain elements of the data, either to do some detective work, or some make good, something didn't happen the way that we thought it was going to be, we've got to find out where all that data was. So they had to send an email to this small army that maintained this massive Excel spreadsheet, and then request whatever data output they needed, which they would then scrape it and then email it to them. It's like, well, wouldn't you love to have this massive spreadsheet that has all of this ingesting data and stuff synchronized all around, that everybody is able to maintain this and basically automate it. And so that's the one to where it perked up a lot of ears, because a lot of people were sitting here going, this is wonderful. And it's like, do you work with Excel? Yes, we do, and I'll get to that in a minute. So just a little bit of a workflow diagram. When we submitted our proposal for our talk, we were very high level, very non-technical, and they said, you need to put some technical stuff in there. So this is basically to really kind of assuage the people over there. But you're looking at a very common, simplistic workflow, to where you've got a workflow is a aggregation of work steps that need to be consumed by work group members. And so if you sit there and you look at, it started off in work step one, work group A member starts an input that is then going to be put into the work step environment, which then has to then collaborate, which is then going to be joined with inputs from additional members. And so how do we actually, and that moves it to work step two. What do we do together with what we have just combined? So the baseline protocol stack, just giving you a little bit of an architecture diagram, if you guys want to sit and take a look at it, is really how all of this puts, and this stack is not very dense, and that's on purpose. We don't want to have anything that is going to start to have to rely on other vendors for firmware updates. We want to be able that this is going to function 24/7, regardless of any type of external challenges. And so you can basically start looking at your CCSM, that's your consensus controlled state machine, the abstraction layers. You can start to put custom interfaces, and that we can do bespoke, but you need to engage one of the baseline partners to actually make that happen and really help you, or hold your hand and take you down to where we can have that custom interfaces. But that's not something that is going to be done just right off of the shelf. Does everybody have this one down? So we went a little bit of the mid-level architecture, and we're using as just an illustration, just a transaction between a buyer and a seller, just to make it as easy as possible. So you've got the buyer that is going to go ahead and have their state object, whether it's going to be an invoice or whether it's going to be a physical good or whatever, that is going to make it through the API gateway, which will then go through the baseline protocol core stack. And that is where the zero-knowledge proof is generated. And then that is then allowed onto a different abstraction layer, and that is going to be platform dependent. Primarily if you're using Ethereum, you will need that CCSM abstraction layer to actually coordinate if you want to have any type of scale. But at the same time, you have that CCSM layer, that is where we have the bulletin board where we are storing all of the zero-knowledge proofs. Everybody kind of clear on this one? So if you want to actually kind of, expand this out to a party, it plays just as well with it. We can actually scale this out to where if you want to put, 100 external parties or even 1,000, we can go ahead and handle it, just so long as you have the plumbing that will be able to handle that type of traffic. We can actually make it happen. Again, you don't necessarily need the abstraction layer if you don't necessarily need it, but if you're going to be using, public blockchain or that, type of architecture, you will need this. It will go much better. But at the same time, we have that bulletin board that can be handled in a distributed, append-only fashion. Nobody can go back and rewrite history. We're good? So if you look at a simple purchase order, kind of looks like this. This is just kind of a regular workflow outside of baseline protocol. So everybody creates a purchase order. Is it approved? Yes, no. Your regular workflow diagram between a purchaser and a vendor. And mother Christ. Create invoice, sign invoice, receive goods, all of that. This is how it works within, just an illustration, how it works within baseline. You've got an API call against the contract logic, which is already established by the organizational or the counterparty agreement. It's going to generate a cryptographic proof of the contract compliance and update the contract state to say you have accepted the terms and conditions, you are attesting therefore, and so is your counterparty. Any questions on this one? It's really, mother. Yeah. I had a full battery before I actually started and figured it was going to make it through the entire session. Yes, don't go anywhere. This might. How's everybody enjoying Denver right now? It's really, just, some say it's like in a European city, but, really all the signs are in English. I mean, I don't know. There we go. So this is a fairly simplistic way where you basically have the APA calls, push and pull, and generating the acceptance from the contract logic, and basically making sure that everything is aligned and everything is acknowledged. And it's done very simple. And so then you have the proof that is going out. Their API engine will validate the proof. Yes, it's on the up and up. And if they want to have a question on it, it will then say, do you want to go to the bulletin board and decrypt it, before that and stuff. Even though you are getting the proof that, yes, this work step did happen on this such and such a time, and we were able to actually move forward. So Baseline Protocol is an open source standards-based body. We do not have any commercial interests ourselves because we are the ones incubating the IP as well as advancing the standard, which has been ratified and is under the OASIS umbrella. And we are right now a volunteer army actually bringing this forward, and so we welcome any and all that want to come in and get involved. If anybody wants to come in and contribute to the code base, we have an entire system of entire group of core devs that all work under the common purpose, and you can find basically everything on the GitHub in this link that we have here. And I put a lot of these business cards on there. Come to find out that the QR code is no longer valid that they put on there. And so I've got a pretty angry text to my marketing team going, did someone just not think about this? And yes, I will incorporate it into my talk where what happens within a multi-party environment where somebody just didn't do something that they were supposed to. Where did it break down? We can't complete our workflow. Where did it happen? And how do we make sure that this doesn't happen again? So this would be a prime real world example that we have on this. So A couple of use cases, and I'm going to jog through this because we're actually running short on time. Within financial services, you have one thing everybody knows: banks don't want to share information, not with anybody. But they still need to get insight, and they need to get some type of, of decision-making material from the data. And so how do we go ahead and do it? Well, we do this really manual friction process, and we play this game of go fish. And if you start looking at any type of lending environment or debt management environment to where you're going to have multiple parties that are going to be contributing to that entire profile, but they can or will not share data, this is how we can actually put it together. Better fraud protection pretty much comes from the synchronization that all of the people that you have allowed into your workflow environment are properly allowed to be there. Probably one of the big things is the reduced friction from the data intermediation. We need data from somebody else. They're not going to share it with us. We don't really want to take custody of it anyway, but we still need to complete our workflow, with these external partners. This is a way that we can do it and maintain all of our compliance. And then also this will increase access to financial services because it's a safe use of sensitive information that is pooled from multiple parties but shielded from any prying eyes. We did one within the EIF study that is starting to within small business lending and financing because you have a lot of the larger banks really don't want to mess with the small business lenders, okay? We want to deal with the big fish. How do we make that process easier that we can go ahead and do this and automate it as much as possible, but we still need to do all of the exact same workflows and project milestones that we need to do if we're doing a more complex, larger financing arrangement. This is a way that you can actually go ahead and get everything that you need, know that you're synchronized so you can get your decision making in any type of disbursement or any type of finality that you're looking for. And this is one that a study that we put in that was funded by the by the EIF, and to enormous applause that we had. So definitely kind of watch that space. Another one we did with a use case specific to financial services was zero knowledge cryptography to bonds. And if someone wants to start looking at issuing a bond and they want to buy a bond and they want to get quotes from multiple counterparties, none of them want to share any type of data. And so how do we actually, in this bifurcated flow, this back and forth, this is what these are the parameters that we want within this particular corporate bond. And you need to know that insight without actually taking custody of that data. This is the way of making it happen. And then also, if you go and look within the code base, you've got just search Boris Breslov, who was up until recently at JP Morgan. He did a lot with this. Baselining Excel. This is the big one. 80% of all businesses are going to rely on Excel. And I don't even think that Microsoft understood what they were really, the tiger they had by the tail when they originally put this out. They just wanted to do something that was easier than VisiCalc. And oh boy, did they ever hit that target. Bank reporting, asset management, audit and compliant, even just any type of data that needs to be at least collated, curated, maintained. Everybody uses Excel. And we have a baseline connector that is going to allow counterparties through zero knowledge to be able to prove consistency or the lack thereof between your data sets. So if somebody makes an update to a field, you will know which field is updated because you now have what we call a baseline false. This is not aligned with your counterparties, so you need to go to that field. We're not telling you, hey, it doesn't match. We're going to tell you this is where it doesn't match. And so if you start looking at all the audit and compliance, which is all happening on Excel, mainly because that's what the regulatory bodies are accepting it in, because that's what they know and that's what they're used to. All of this stuff, that was one of the things that we wanted to do to gain traction was we had to be able to have that commonality and to get everybody using what they are already familiar with and actually making it easier. And I keep telling everybody, yes, it is that simple. So this is a way of actually getting involved. join the team. We meet on YouTube at noon Eastern time every Wednesday. So you'll see me, or actually you can go through, we've got an entire library of videos just within our channel. Definitely go ahead and join the Slack. Get a lot of the crosstalk that we see, all the people, within the core devs, what they're talking about, and all the people within the outreach team, which is what I chair. How do we actually get people excited in using this? The non-technical people. Basically, that'll say, this is what it will do for you. It's going to save you money, it's going to make you money, or it's going to keep you out of trouble. That's the three legs to every stool. That everybody's going to try any type of new digital transformation. I want to make money from it, I want to at least save money, or I want to stay out of trouble. That is what we have. So here's some of the resources and stuff, and none of these are, are clickable. Actually, yeah. Oh, we're never mind. That's going to basically get me to that. But that's basically what we have. Does anybody have any questions, any answers, any dirty jokes, any things about it? I mean, been able to really kind of, clear some fog, or at least cross a couple of paradigm shifts? Anything like that? From the proof, you will not be able to. Now, you may have, just through your normal business, to know that you're talking at Bob over at ABC, or you're also talking to Alice at XYZ. You're talking to them, but as far as the actual data, we're not really disrupting any, relationships or anything. This is just a way of saying you're going to be able to do something that you weren't able to do before without getting into big trouble or costing a lot of money or somebody looking for you to be the throat to choke. So, and again, it is that simple, and we do, and some people say, oh, it's blockchain is middleware. And I'm like, yeah, it is, and that's how we came up with. But right now, blockchain is not a requirement. If you want to be able to create your own append-only bulletin board, by all means. But the big meat within this is within the ZK engine, the zero knowledge proof, to where I can't show you the data, but I am proving to you, not just attesting or assuring you, that what I have is matching what you have. That right there takes so many elements of friction out of it. It straightens so many curves and smooths over all the edges just in that process environment. And so that's why we did it. Let's do something that's going to make it easy, as simple as it's supposed to be. So. Mm-hmm. Well, the first thing you would do is you would want to go back to the proof of that actual transaction. And that transaction did not mean that there was a data exchange. It just meant that there was a proof of the synchronization. So at that point, if you needed to go back, you could sit there and say, well, at this point in time, this is what my state was, and this is what their state was. And you can actually automate that to where you can go back and say, yeah, this happened. This happened the way that we were supposed to. Maybe we didn't have the right intel. Maybe we didn't have the right instructions, or something changed that we weren't aware of yet. And now we've got to go back and make it good. But we now know exactly where to go and where to find it.
Well, I guess my question is not, in the case when you're not actually doing data synchronization,
Mm-hmm.
right? And you're essentially, if I'm wanting to compute over some data that someone else has,
Mm-hmm.
right, and I don't necessarily want to have that access to that data all the time,
Mm-hmm.
I want to be able to maybe take the proof, and that's enough for me in some cases, but
Mm-hmm.
in some cases I need to actually go and get that.
But you need to do that computation within that trusted execution environment. That's similar to what we talked about with telcos, because telcos have these enormous data lakes, and they are prohibited from actually sharing many attributes of that data. But they want to monetize it so bad, and there's an entire universe of people out there that want that data that only telcos can give as far as location and movement. And it's all happening at a network layer, not so much at an app layer. And so that makes it even more attractive. So you can start up and put together a trusted execution environment to say, these are the parameters that I need for my query. Okay, and then you can engage a counterparty within the telco and say, this is what we need. Compute again that, you will give us the output, the insight, in a zero knowledge proof. to saying this is what we had, and we are not running afoul of any compliance, and no data is ever leaving their enterprise. But you have your insight and your output. So it gets a little bit interesting to where you have to have these people that say, I need these really large data sets that I need to ingest into my AI ML engines and stuff. How do I go ahead and do that? And so that's where we're really starting to do a little bit more work there, because you can't go to like Snowflake or Informatica, because most of the times that data is too old or it's sanitized in a way that doesn't really work with your AI ML engine. So do you need to go? So doesn't work well within your AI ML engine and stuff. So what do? This is a way to where it's like, okay, we can go ahead and give you insight into this so that you can, ingest it. Take care. And then go ahead and whatever output or insights that you want to glean from that data set. But it's basically a way of saying, I can do this without ever actually seeing the data. So, anyone else? Excellent. Well, thank you for your kind attention, ladies and gentlemen.